Okay, let's start with the first part of question 14. I actually spins the spinner twice, and the probability it lands on one both times. So the probability it lands on one is obviously a third, and it's going to be a third for the first time and a third for the second time. One of the mistakes you often see is people adding these two. Well, a third of the time it's going to land on one, and a third of those times it's going to land on one again. So it effectively means that 1/9 of every time she spins the spinner twice, she's going to get a 1 followed by a 1. You multiply when you're dealing with successive events. So probability gets 1 the first time is a third, probability gets a 1 the second time is a third, probability gets a 1 followed by a 1 is going to be a third times a third. If we then look at the probability tree question in the second part, obviously the probability of getting an even number on the first spin is a third, probability of getting an odd number is going to be 2/3, so the probabilities have to add to 1 for every stage. And the probabilities don't change, so it's going to be a third and 2/3 for the second spin, and a third and 2/3 for the third spin as well. Now, the other thing is the, oops, I've done that the wrong way around. Oh no, sorry. For this bit at the end with the outcomes, you'll notice that they've used the system EEE and EEO to write a shorthand for even, 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 and even, even odds. So you can just carry that on all the way through. Not hugely complicated. So you get EU, OE, OEO, UE, and OO. The probability of getting an odd number 3 times is going to be odd followed by odd followed by odd. So it's 2/3 that it lands on odd the first time, 2/3 that it lands on odd the second time, 2/3 that it lands on odd the third time, and that gives you the result of getting 3 odds when you spin the spinner 3 times. To work out the probability of that, you just multiply along the branches. So it's going to be 2/3 times 2/3 times 2/3. Which gives you 8/27. Now, to work out the probability it lands on an even number exactly once, we need to look at all the different outcomes which correspond to that. So that's this one, and this one. And we're going to add together the probability of those 3 outcomes. So starting with the top one, EU, that's going to be a third times 2/3 times 2/3. And then the next one, OEO, is going to be O, E, O. We multiply along those branches to get the probability of that one. And then we do the last one, which is OOE. You'll notice that the probability for each of those 3 outcomes is the same. So you could just easily work out the probability of 1 and multiply it by 3 in this particular case. The probability of each individual one comes out as a third times 2/3 times 2/3, which is 4/27. So you get 4/27 for EU, you get 4/27 for OEO, and you get 4/27 for UE. And with those 3 different outcomes that all correspond to the result we want, we add those probabilities together. Now, I guess there's a confusion sometimes as to why we add for some and subtract for others. The key thing here is that we're adding 3 different final results. So at the end of spinning the spinner 3 times, we have 8 different possible outcomes, starting with E and ending up with OO. And if we're looking for ones which land on an even number exactly once, there are 3 outcomes, the ones we just worked out, which correspond to that result. So we take all those different results and we put them together as one, as all the different possible ways that fit the result we want. For each of those individual results, so to work out the probability of getting EU, we multiply along the branches to work out the probability of EU as being 4/27, and the same for those 2. And then to work out the probability for a combined set of outcomes, we add those up. I hope that's